Welcome back to C++ with Miyoshi. Few more things about random numbers, just a little bit more about random numbers. Today we're going to talk a little bit about random floating point numbers. So, again, recall that if we have srand, we call srand at the beginning of our program so we can seed our random number generator, and that random number generator creates what amounts to a list of random integers between 0 and rand max. And any number in that list is equally likely to get selected as the next one as any of them. So they're all equally likely because the last selection of a random number should not depend, or the next selection of a random number should not depend on the last selection of a random number. So think of that again as an infinite list of random numbers. Now over here I have a little bit of code, and again remember that you need to make sure you have your pattern include time.h. And if you put at the top of your code this srand unsigned time null, you will get different random numbers every time you run the program. If you ran the srand with some constant in there and you run the program, you get the same exact sequence of random numbers every time you run the program. So most of the time we want to do this probably. And again, if you were doing some encryption or some other really cool stuff, you might not want to use the random function that is included in your normal compiler. You're probably going to want to use some other really cool random number generator. But for our purposes, it's beautiful. Here for a random floating point number, you want to make sure you do, well, here's the recall that we want to do our random integer. We just do int rn is assigned the value rand, open close parentheses. When we call this function, when we do this, this is going to give us between 0 and rand max, exclusive of rand max. So if we just call rand, it's going to just give us those numbers, any of those numbers. When we want to do a floating point number, we have to do something a little bit more complicated because, well, we do. We have to do what's called typecasting. So I do float rf is assigned the value float rand divided by float rand max. Now, if you recall, hopefully you recall, typecasting, or some people just call it casting. Typecasting, what it does is it makes whatever comes after the variable name, or the type name in parentheses, whatever comes after that is going to be made into, for this statement, into a floating point number. So this float rand is going to make rand into a float for this operation. Then we do this divided by float rand max, and that's going to make rand max into a float for this operation. And then we divide it, that way we get floating point division, and I can have some decimal points in there. If you didn't put those in there, you would only get 0 or 1. Those would be your only outputs. The only problem is if you did that without these floating point floats in there to typecast, you would have 0 almost all the time, and every once in a while, every great once in a while, you would get a 1. So that's a great tip in terms of debugging, by the way, if you ever see that happen. Check to make sure you got your typecasting in there for floating point random numbers. And again, this gives me 0 to 1, and it's inclusive of 1.0, not exclusive. So if we want it to be exclusive of the 1.0, what we're going to do is rf is float rand divided by float rand max plus 1. And this will give us a floating point number between 0 and 1, exclusive of the 1. Now, how close you get to the 1, well, we don't really kind of know how close you're going to get to the 1, but it's going to be close enough for what we need to do. Okay? For most cases, at least in the beginning. So then here's another one. Let's say we don't want to have just random numbers between 0 and 1. We want to have random numbers between 0 and 10.5. Well, then we can use this formula here. rf is assigned the value float rand divided by float rand max times 10.5. And that will give us the random numbers between 0 and 10.5 inclusive of 10.5. Okay? The inclusive and exclusive is just determined by this guy here, whether I have the plus 1 or not. Just very similar to the integer types, but those were down in the range, and it's here in this divided by for the floating point random numbers. Okay? All right, so This is an example I use in my book, and then I probably should go on and explain a little bit more. Let's go a little bit farther than that. If I want to have a random number between some range of numbers, I have over here, I created these float min and float max, and f min and f max, and float f range. Now, if I want to have numbers between a certain range, I can surely make that range f max minus f min. And then what I'm going to do is I will do this. RF is f min plus again, float ran divided by float ran max times f range, and that will give me numbers between f min and f max. Okay, because we know that f range is f max minus min. So f min. This will give me numbers between f max and f min, inclusive of f min, or f max and f min, but inclusive of f max. Last thing we have is we have this same thing, but instead it's a little bit more generalized. I changed the f range into its component parts, and so we just want to do the general formula, which is RF is assigned the value f min plus float ran divided by float ran max times f max minus f min in parentheses. So we have, this is exactly the same as this one, except for the fact I just want to be more generalized and do the f max minus f min in the formula. So here are some nice equations for you to look at in terms of determining floating point random numbers. And remember that this ran plus 1 or the ran max in the division, those are what determine whether it's inclusive or exclusive of the maximum number you're looking for. So a little bit of floating point random numbers and a little bit more recall about what random numbers are in C++ and most other languages that have random numbers. Again, they're just a list of random numbers, and in our case they're between 0 and ran max, and so that's how you get some nice floating point numbers to run your programs. So thanks for tuning in. We'll see you next time on C++ with Miyoshi.